welcome to today's lessons. We would want to see how to determine if an ordered pair is a function or not. So we spoke about how graphs are seen, how graphs are determined to be functions or not using the vertical line test. And we also saw in the previous lesson how to test for an equation to see whether it's a function or just a mere relation. Now let's see this kind of questions. So first of all is to see the function in the table. We have 0 mapping to 2, 3 mapping to 4, -3 mapping to -2, and then 2 mapping to 4. And right here we can see that each member of the, so if we should write it as an ordered pair, we would have 0 to 2, 3 to 4, -3 to -2, and then 2 is to 4. So we can see that every member of the domain is mapping, so-called domain, and then the domain. So every member of the domain is mapping to exactly one member in the codomain, or each x value has only one member in the y value. So let's see the next set of questions. Now, which set of ordered pairs represents a function? So let's look at the first one. In this first one, 2 maps to 3, 2 maps to 6, 4 maps to 8, and then 7 maps to 13. Now looking at this, we can see the x value 2, the x value 2, and then it appears here as well. So on one occasion, 2 maps to 3, and at another point, 2 is mapping to 6. So we can therefore say that the first ordered pair is not a function. It's not a function since the x values are not unique. Alright, so the second question, 2 maps to 3, 3 maps to 6, 4 maps to 8, 7 maps to 13. And right from this question, you realize that each x value has only one. 2 has just one y value and doesn't show up at any place again. Therefore, this is a function. The third one, 2, 3, 3, 6, 3, 8, 7, 13. And here, this 3 has made them to lose their sense of being a function, since 3 maps to 2 different values. It maps to 6, and you also have another y value 8. So 3, 6, and then 3, 8. Therefore, the third one is not a function. Now let's see this other one. 2 maps to 3, 3 maps to 6, 4 maps to 8, 7 maps to 13. You can see every member is unique. 2 is exclusive to 3, and then 3 is also just exclusive to 6. So they are all well lined. So the fourth one is a function. And then the third question, which is C, is not a function. Okay, so this applies to how we're going to answer this third one as well. So which set of ordered pairs represent functions from A to B? So A is having a set of numbers in the domain. It has A, B, and C. The codomain has 2, 3, 4, and 5. So let's see. C maps to 2, B maps to 2, A maps to 5. So each member in the domain has only one member. So C maps to only 2, B maps to only 2. So even though 2 is connected to both C and B, it is still not a function, since C has 2 to himself, B also has 2 to himself. Alright, so A maps to 3, B maps to 4, and then C maps to 5. This second one is also a function. So a function The third one, 3 maps to A, 2 maps to A, 4 maps to C, 5 maps to B. So these are all. So this looks a little bit tricky, and I hope you've been able to see that. So you see that in this case, you likely pay attention to this side. because actually the question has been reversed as compared to the first two, where the writer puts, so this is the output, the yx, 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 and then yx. Can you see that? So we realize that this x value, which is a, has more than 1. So goes here. So a goes to 2. So the domain, a value in the domain has more than one output value, or an x value has more than one y values. So a has 3 and it also has 2. Therefore, this is not a function. Let's see the last one as well. So a maps to 3, so it's reversed again. So x and then y. So a maps to 3, c maps to 4, c maps to 5, and then b maps to 5. And right here you can see that the c value maps to 4 here, and then c at the same time maps to 5. So we can say the x value has more than 2 or more than one value in the codomain. So that's how we are supposed to see it. So therefore, I hope by this we can be able to explain or see the difference between functions and relations, even if they come as ordered pairs. So thank you for being a part of this lesson, and see you in the next class. Bye.